Hello everyone. Today we come back again at another episode of CPE100. And today I would like to continue with the last video that we're gonna talking about the computational thinking. What is that is how the computer works in general, how they think. So simply speaking, is computer is not like human. When we learn at some point of times, we doesn't need to explain what we think. For example, when we run, we never think about running anymore. We just like thinking about running and then immediately we run. But at the starting point, when we are babies, when we are unknowns, thinking about a kid who doesn't know how to multiply or adding the numbers before, then you need to be able to explain your thought process. And especially when you want to program some things, you need to explain it in sequential order, in procedure that machine will understand, that you can translate it into programming languages. So they are like only for rule of thumbs, for explaining the way you thought in systematic way, and then you can translate it easily to be the program later on. Okay, thinking about this number 44. Why it is 44? And then you might ask, like, I don't know, is it 44? I see the number and it's 44. And how about the kids? How about babies? Like, they never saw this kind of numbering before. They will be like, 4. And father and mom is like, no, it's 44. Nah, 4. Like they doesn't understand how to translate the numbers into value when it have more than one digit. But after you study mathematics, somehow when you see this number, your brain working like this. Your brain translate this number into 4 in the second digit, and then this 4 in the first digit. With a lot of mathematics assignment that you done when you were a kid, it simply translate this second digit to be 40 plus with this one, which is 4. And moreover than that, with a lot of mathematics assignment as well, when you're training, when you were junior high school, this one is simply 4 multiply 10 power of 1 plus 4 multiply 10 power of 0. And then in the end, it's equal to 44. You did it so many times, like million of times, until you learn that whenever the number came in order, you can translate it into value by adding the digit value in it, right? That's the way your brain works in general. Then when you're talking about the computer itself, when you see the movie, when the computer like think in binaries, that is have a lot of number of 0 and 1 0 and 1 0 and 1 0 and 1, for example, like the Matrix. Okay, Matrix will be a little bit too old. Some of you might not born yet when the Matrix is popular. I'm also quite old now, so I cannot think about like the modern movie that talking about binary number that much. But Matrix is so good. So Keanu Reeves, he's so handsome at that moment in time. And we're gonna talking about our lesson here that binary number also translate into human value in the same order, in the same thought process when you see that 44 numbers. Basically, if you have this sequence of number came in, the way computers thought, because like they were in 2-digit system, not 10-digit system, not 10 base system in general. So the value for each digit is translated in the same way that your brain works, but instead of 10 power of 0, 1, 2, 3, 4, 5, it's gonna be 2 power of 1, 2 power of 2, 2 power of 3, 2 power of 4, 2 power of 5, 2 power of 6, and 2 power of 0. This is the value of that specific digit. So when and like I translate it back, okay, to be this simple numbers that you can understand in 10-digit system. So what they did is they multiply 0 or 1 with the value of that digit. So basically this arrangement is going to work like 0 multiplied by 64, which is equal to, okay, 0 multiply 64 plus 1 multiply 32 plus 0 multiply 16 plus 1 multiply 8 plus 1 multiply by 4 plus 0 multiply the star multiplied by 2 plus 0 multiplied by 1. So this one is remove out, remove out, remove out, remove out, and you're gonna have like 32 plus 8 plus 4, which is equal to the number 44. So this is how 44 that we understand being translated in the 2-digit system that computer being understand. Even in the end, the value is totally different, but the way we interpret the value of the order of number is the same way of thought. Okay, instead of 10-digit system, we just change it to 2-digit system. And if you ask why it have to be 2-digit system, it's simply because computers is made by electronic device, is digitalized. So maybe we just doesn't need this one yet. Okay, but then what happens inside the computer is every single grid of that CPU, they have a million transistor. Transistor is look like this, and it's work like a switch that can trigger only 2 states of it, either on and off, when you assign electricity in it. So scientists and engineer will build the system. They just say, okay, if the trigger state is on, is 1. If the trigger state is off, is 0. That's why computers can work only in 2-digit system. I mean, in the backbone of it, it's just 2-digit system. Okay, so this is what it is. And then I would like to have some question that you might play around by itself. We're gonna do it on hand here as well. That question that how can you translate the number, which is it can be hours, centuries, or years, month, date, and whatsoever into binary system. Okay, so basically you need to invert this thinking process quite a bit. So you need to invert the way we think about translating binary numbers to be 44 into changing like 10-digit number to be binary numbers. So the way we think is like this. We need to find that what is the closest number of 2 powered by x that is not more than 2, 5, 6, 3. Okay. Why? Because, as I say, it can be only 0 and 1. When it can be only 0 and 1, it means that the value of that digit can be either 0 or the digit value itself, which is 2 multiplied by x. Okay, then if we found the closest number of 2 multiplied by x toward 2563, then it means you're gonna find the first digit of this binary sequencing. Okay, and we might say like 2 multiplied by 10 is 1024, so it should be 2 multiplied by 11, which is 2048. Okay, so it means this is the sequence of what is sequence of 12 digit binaries. Why 12? Because the starting point here is always been the digit value powered by 0. If you remember, it's 2 powered by 0, or back in our human 10-digit system, it's going to be 10 powered by 0, right? When the first digit is at 2 power of 11, then the first position should be at the 12th position here, which is have to multiply by 11 of the value. Okay, and then what you did is you subtract, okay, 2563 with these numbers. In the end, it's gonna have like 5 here. You did the same things that you're trying to find the closest of 2 multiplied by x, that not more than 515. Okay, you repeat this process until the value equal to 1 or 0, which is the last digit. Then you can make the sequence of binary numbers. Okay, this kind of simple, but somehow we didn't think about it before. But we need to thought in that sequence of order before we can translate our thinking process into the code, into the program. Okay, so yeah, for one data in computers, we call it 1 bit. 8 bits is called a byte. And if you remember, this is the unit that you use for the storage or memories in your PC, in your mobile phone, in your tablet. All of them called in bytes. Okay, if they say million bytes or megabytes, it's gonna be a million. If it is gigabyte, it's 10 million. 1,000 million. Okay, that's pretty simple. Okay, then with this question in mind, that how computer learn our languages, because if it is a number, we can say like, okay, we can directly translate from 10-digit system to 2-digit system. But how they know A alphabet, B alphabet, Ko, 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 Ngo, or hiragana or kanji or any other languages on keyboard? The way they did is simply change the keyboard itself to send the numbers in binaries, and then they create this kind of matrix, which is this one is pretty old one but not complex. I want to show this one to you that okay, they create a standard which is ISO standard to implement the keyboard, and each key in keyboard need to send out the number either 0, 1, 2, 3, 100, 200 something, 250 something. This is how machine really work. So your keyboard didn't send alphabet A. Your keyboard send number. If it is capital, it send number 65 to the machine. Then machine has this table inside the computational unit and translate that number 65 into number A. This process called encryption or decryption, which is you're gonna learn in high-level programming later on. But keep it in mind that in any single way. We need to find a way to engineering the process that can change the number into something else. Change number to characters, change number to alphabet, change the number to be images, change the number to be video, or use this number to making operation or translate it by like change the way that the multiply or addition or subtraction, simple mathematics can do and operate in sequential order and can translate into any other function. Okay, so as I mentioned before, input is something that predefined. I would say like it's predefined in abstract form. For example, if you want to make a face recognition code, then simply speaking, the input is gonna be human face in abstract form. Okay, you don't talking about the size of it, you didn't talking about the race of people that you're gonna use it, you don't talking about how the shape and form, fat and thin people gonna interact with your code yet. You just predefine that okay, it's gonna be human face. And then for the output itself, it's gonna be something like detecting emotion, for example. So the output also work as a predefined in abstract form as well. Why? Talking about face recognition system again, if you say like you need to detect emotion, then you're gonna talk about it in very abstract layer first when you design the programs. That okay, it need to detect angriness, sadness, boredom, or worriness, or worriness is a word? Not really sure. I'm pretty bad at English actually, so you can correct me in the video below. Any other emotion? But anyway, disgust, for example. You need to talking about in very abstract way first. Then after that, we will put these two things together to design the systematic and driven, logically correct and abstract representation of the process. Okay, that's what we do. We design, and then somebody need to translate it into code. Sadly, that in this subject you need to do it by yourself, but that's not the main point of the course for me. For me, if you can design it and is logically sound, it's good. It's good. It's correct. So come back to kind of activities that you can do with your friend or your family and try to thinking about it a little bit more. It's a game. I don't know how to say it. I didn't see it in Thai before when I was kids, but in US or in UK, they always play this game with the kids, and they even have application that do this. So it's called 20 question. Simply speaking, they will have like two person. They will have like one person and another. So this one is two players. The player will imagine one thing. For example, he imagined a cat in his mind. When he's ready, he will say like, okay, I'm ready. I imagine one thing. Then the guesser have only 20 questions to ask, and it have to be yes, no question. Yes or no. Okay, asking, for example, is it object? Yes or no. Is it tall or it's short? Or is it tall? Yes or no. It cannot be tall or short. It have to be yes, no question. Okay, and they have only 20 questions to ask until they can guess that is it a cat or not. If they can do it in 20 questions, this player win. But if they cannot do in 20 questions, then this player win. Okay, this is quite fascinating kids game, and But if you're thinking about it, nowadays they have an application called 20 question, and you can play it. It's almost all the time can guess what you think in 20 question. The AI inside have the way to asking question until most of the time they can guess that what do you think in your mind. How it work. So if we try to reverse engineer that application, we need to play a game first, okay? For example, the item in the room that I'm thinking about, and then my wife might say like, okay, is that big, or is that short, or is that long, or is that whatsoever? So you can try to make it harder and harder until something like what is the item that I'm thinking about, or what am I thinking about, which is extremely difficult because you doesn't have environment queuing or any scope of the result that you can imagine about. But they always have only two ways. You can pause here first, you can play it with your family first, and then come back that you see and observe these two behavior or not. Okay, we will continue in 3, 2, 1, go. So they have two type of people most of the time. You're gonna say people will ask, is that table, is that pencil, is that microphone, is that this PC, is that a pen, is that... So they ask item by item, one by one. And that's one in computers way, or in the way of thought, we might call it brute force process. It's like you put a lot of effort to asking like one by one question, like, okay, is that number, is that mouse, is that keyboard, is that... You doesn't try to scope down the result or searching space at all, but you just try to ask it one by one and beat it one by one. And it's a lot of effort to do that. Another type of people will asking this kind of question, like, is that electricals? Is that require electricity to work? Yes or no? Is that made by wood? Yes or no? So whenever people say yes or no, you can cut down the searching space. For example, like this is our office work in the world. When you say like, is that require electricity or not, you can divide in half. If yes, it should be something like mouse, computer, refrigerator, or something, not table, not chair, not something else. So this one is called divide. So you divide the searching space, and then you conquer. Whenever people say yes or no, you conquer one searching space and you try to scope it down until you can guess what it is. Then you switch back to use brute force method. Okay, they mostly all the time have only two way of thought in human brain that's gonna work in this 20 question challenge. What happened is these two methods can work quite well, even though we're changing topic. For example, if we don't asking about item, we asking about jobs, we asking about chatbot that guessing what I want in Lazada mall right now, or Shopee with the sale 2 and 2 sale in 2 or 3 days ago, for example. The guessing bot or guessing system can use the same way of thought to finding solution, even though it's a different question. So that is the thinking process that we want from the class. Okay, whenever you create a thinking process, you need to be able to abstract it down until it can be something that reusable most of the times. Okay. So again, this one is gonna be a question. You can try it by yourself. Like if you have a deck of cards, it doesn't have to be 1 to 100 or 4. It can be just like simple deck of cards that have number 1 to King Ace. Okay, 1 to A is gonna be 1, 2, 3, 4, 5, 6, 7, 9, 10, and it's gonna be Jack, Queen, King, Ace. Right? You try to sorting the card in order whenever like you throw it away or shuffling it to be random order, how you did that. It's gonna be challenge that I would like you guys to, thinking about it write it down into the way you sorting that card, okay, and then post it in the comment of this video. I'm gonna make a reflection of the way you thought, and I will try to simplify it down using the computational thinking to change it back to be algorithms, to show you as an example of how to apply computational thinking method to working around and create the thought process that computer can follow. Okay, so the component of computational thinking have only 4 main components. It have decomposition, abstraction, pattern recognition, and algorithm design. Okay, decomposition simply mean break down the question until the extremely small one that you can scope down and have only one sequence of process to solve it. For example, how to write an essay, it's going to be extremely difficult to randomly write it down. But if you're thinking about it to have like 3 parts, introduction, body, and conclusion, then you can break it down even more that each body, paragraph, how I gonna write it down. It can be like class review, it can be facility in campus, it can be impressive moment in campus. So if you break down until it is become very, very small part that you can handle, then it will be easier to thinking about how to write each paragraph one by one. So it's like you're making the script. You're breaking down your problem until it becomes small chunk that you can think about it clearly before you mash it up together later on. Okay, so pattern recognition is the second process. So when you're breaking down the process, you're trying to find the similarity of the question. You might say, for the essay, the paragraph 1, 2, and 3 almost can be made in the same way. I will talking about what we have in the campus first, and then what I'm expect in my mind, and if it have conflict or not, and then resolution that I'm prefer it or not. Then if you use the same sequence, you can write paragraph 1, 2, and 3 that reflect about facility, campus, life in university in general, or even your class in general, one by using the same patterns. This is pattern recognition. You observe small problems and try to find a pattern between them. Okay. Next, this one is a kind of like example that I want to show is how to bake a cake. Then you find a cake recipe, and I would like you to observe that is it have a pattern in how to baking a cake or not. Okay. So for the abstraction, this word is going to be difficult to understand, to be honest. I mean, it's easier for people in art, like student in multimedia, or anyone who have been work in the artistic world for a while to understand it. Abstraction is simply mean focusing on important information about something. Lean down the information, remove the detail out until that is the minimum information that can represent something. And then you're starting to say, like, shaking your head, like, what are you talking about? So I don't know, like, it's gonna help you or not, but like the abstraction of the cats, regardless of subspecies of it or the race of the cat, what it has to be, it needs to have 2 ears. It has like pretty small triangle nose. It has pretty, you cannot say it have a hair, right? But it have a head, because some cat doesn't have hair. It have this cute mouth. It had a tail, long or short, regardless. But it cannot differentiate cat and dog yet. For me, it should say that the cat gonna have the long twigs that can help them on the face to longer than their face in general to help them detecting emotion, and that's it. They have 4 pawn, right? They have 4 pawn, oops, and have the body. This is extremely ugly drawing, but anyway, it can abstract down the representation of cats. So the same question with abstraction of maps. If it is, all the map is going to be a little bit difficult, but if you're talking about subway maps, okay, here is what the subway map look like if you lay it down with geographical location. So it's extremely hard to see which station different from another and how the line interconnect with another. So the way we represent the maps is always like this, right? So basically what we do is we lean out the location and direction out of the scale. Why? It doesn't need it, right? When you put in the subway, you didn't see the environment in the ground. You really just want to know, okay, where is the next station? What is the name of next station? And is that connect to another line or not? What is my previous station? Where is the end of the line? Just that. And then this one is going to be cleaner and easier to represent the metro or subway map. And that is the one that we use nowadays. In the past, people ever used this one before, and people hate train. People hate metro system. In London back in 19th century, it's pretty hard to see what is what. But until this kind of map being implemented, life become a lot easier. Okay, this is abstraction. So it's minimize the information until it still represent what is still represent the thing that you want it to be. And then come to the last step. The last step is design algorithm. Algorithm is mean process, thinking process, the way process being written down in words or in sequence of order. Okay, it should be step by step toward the solution to solve some specific problems. Okay, so you have to determine the right step in correct order, and the program gonna follow the step completely like what you say. There are words by the wise man, I'm not sure who said that in the books, but he said technology is made for people, not vice versa. Technology made for serve people, not vice versa, which just means that what you write down in the program is gonna following that 100%. It doesn't change. Okay, so the man who made it know how it works for sure, and that's why the verify of that algorithm can be worked as well for the verification, because you design it, so you can create a test condition for it. Then you need to determine after verification that it is the base approach yet or not. Okay, so that's it for 4 main steps: decomposition, pattern recognition, abstract it down, and then you write down step by step. So for example, if we're gonna play that 20 question words, then what we did 20 question games. If it's guessing only numbers and we want to create the AIs for that, how are we going to do that? Okay, I would like to put it to be, like the challenge first, that please make your own idea below the comments. But first of all, you need to imagine about that divide and conquer first. divide and conquer, and then they're gonna keep divide and conquer until when? That they start switch back to use brute force to asking the number one by one. Okay, this is the process of thought that you need to imagine about it. Also, another question is sorting the card in the deck. If you have any ideas about it, you can written down the algorithm that you design in the comment as well, and I will make a video to review it later on. Okay, yeah, that's it for this episode. The next episode, I'm gonna talking about the tools that's gonna help you to written down or create the algorithms in the human languages, to writing it down as a note taking and help you a lot in the coding process. If you can make that one, life gonna be easier when you're writing C languages or any other languages later on. Okay, thank you for today. See you around. Bye bye.